In history, there are names whose light pierces through 1,000 years of darkness, continuing to guide seekers of knowledge even today. Among them is Abu Abdullah Muhammad ibn Musa al-Khwarizmi, whom we now know as the Father of Algebra. The story of his birth, his upbringing, and the first steps of his quest for knowledge read like the beginning of an epic that illuminated the centuries that followed. He was born around 780 CE in the fertile region of Khwarizm in Central Asia. Khwarizm corresponds to the modern-day city of Khiva in Uzbekistan, a place gradually influenced by Islamic civilization at that time. After the Arab conquest, this region had become a thriving hub of knowledge, culture, and commerce. It is said that his family was possibly of Persian origin, though scholars differ on this point. Yet one thing is certain. The environment of Khwarizm, where diverse cultures, languages, and streams of knowledge converge, was an ideal ground for Al-Khwarizmi's inquisitive mind. Even as a child, he witnessed astronomers observing the skies, accountants busy with ledgers in the markets, and religious scholars interpreting the Quran. His family was likely educated and intellectually inclined, encouraging him toward learning from an early age. At that time, education in Islamic society was primarily rooted in religious knowledge, Quranic recitation, study of hadith, and basic lessons in fiqh. Young Muhammad undoubtedly began his educational journey with these foundational studies. Yet the relentless curiosity within him was never confined to religious learning alone. Khwarizm's geographic location provided him with a special advantage. It was an important city along the Silk Road, exposing him to Indian, Persian, and Greek influences. Imagine a bustling city where traders arrived from distant lands with goods, scholars brought books, and religious leaders engaged in discussions. Al-Khwarizmi, as a child, likely listened to these conversations, absorbing new questions and ideas from the world around him. At that time, the Islamic Caliphate had expanded into a vast empire. The Abbasid Caliphs, in particular, were patrons of knowledge. Baghdad was the capital of learning, where the renowned Beit al-Hikmah, or House of Wisdom, would later emerge. But could a young boy in Khwarizm have known that one day he would become one of the greatest scholars in that world-famous center of learning? Historians suggest that Al-Khwarizmi moved to Baghdad as a young man to pursue his studies. Baghdad of his era was a paradise for knowledge seekers. Muslims, Christians, Jews, and Zoroastrian scholars worked together there, translating Greek philosophical texts, studying Indian astronomy, and exploring ancient Persian sciences. It was the world's largest library and research center, where each book and discussion unveiled new horizons. There is also a deeper significance in Al-Khwarizmi's story beyond time and place. The suffix of his name, Al-Khwarizmi, refers to his birthplace. It literally means the one from Khwarizm. His name became so important in history that when Europeans translated his works into Latin, they distorted it into algorithmy. From this word arose one of the most fundamental concepts in modern science, algorithm. Thus, his birth was not merely the birth of a man, but the birth of a new concept that would shape the technology of the future. It is said that even as a child, he excelled not only in religious knowledge, but also showed remarkable skill in mathematics. In his time, mathematical proficiency was crucial for commerce. Some accounts suggest that his family had business connections, giving him early exposure to calculation and accounting. Yet Al-Khwarizmi's curiosity went far beyond the boundaries of ledgers. He sought to understand the mysteries of numbers, the movement of the stars, and the expanse of the earth. When a child counts the stars in the sky, he may become a poet. But Al-Khwarizmi sought to understand the motion of stars as a scientist. His childhood unfolded in an environment where streams of knowledge converged, and he absorbed them with unquenchable enthusiasm. Al-Khwarizmi's birth, therefore, cannot be confined to a simple date. It marked the beginning of a grand chapter in the Islamic Golden Age. Decades before his birth, the Abbasid Caliphs were already collecting Greek philosophy, Indian astronomy, and Persian knowledge. Al-Khwarizmi was born into this continuum, where each particle of knowledge helped illuminate a new civilization. His birth was a prelude. One day, he would achieve something that would transform human thought. The journey that began in the dusty lanes of Khwarizm would culminate in the golden palaces of Baghdad, where he would light the torch of knowledge. Today, we know that his torch laid the foundation of modern mathematics, astronomy, and science. In short, His birth was not merely the birth of a man, but the birth of a new horizon of knowledge. To understand the life of Al-Khwarizmi, we must turn our eyes to 9th century Baghdad, a grand era when Islamic civilization had reached its zenith. He was born in a time when one part of the world, Europe, was plunged into the Dark Ages, its light of knowledge nearly extinguished, while in the capital of the Islamic Caliphate, Baghdad, knowledge spread like a blazing fire. This striking contrast forms the backdrop of his life. In 750 CE, the Abbasids overthrew the Umayyads and assumed control of the Caliphate. After establishing the new capital in Baghdad, the city quickly became the most vibrant metropolis in the world. Situated on the banks of the Tigris River, Baghdad became a hub of trade, politics, and culture. Merchants brought silk, spices, and gems from the Far East, while crafts, paper, and metals arrived from North Africa and Europe. But it wasn't only goods that came to Baghdad. Knowledge flowed in too. Greek philosophy, Indian mathematics, Persian astronomy, all converged to create a rich and diverse stream of learning. Al-Khwarizmi's adolescence and youth unfolded in this stimulating environment. The caliphs were not merely political rulers. They were patrons of knowledge. The most notable among them was Caliph Al-Mamun, a ruler who believed that the only path to truth was through knowledge. Under his patronage, the Beit al-Hikmah, or House of Wisdom, was established, recognized as the world's first fully-fledged research center and library. Here, scholars translated works from Greek into Arabic, including texts by Aristotle, Euclid, and Ptolemy. They rendered Indian numerical systems and astronomical texts from Sanskrit, and they reorganized Persian traditional knowledge in innovative ways. This institution was not merely a library. It was a living center of learning. Muslim, Christian, Jewish, and Zoroastrian scholars sat together, exchanged ideas, debated, and collaborated. New concepts and insights emerged from this intellectual synergy. Al-Khwarizmi entered this environment and gradually became one of its brightest stars. Caliph Al-Mamun's patronage extended beyond translation. He emphasized practical applications of science. Under his directives, the first observatory for astronomy was built, where Al-Khwarizmi worked, observing constellations, the movements of the sun and moon. Al-Mamun even sent expeditions to measure the Earth's circumference, where scholars calculated shadow lengths and the planet's dimensions. Imagine that, at a time when most Europeans still believed the Earth was flat, scientists in Baghdad were measuring its radius. Political stability also enriched the context of Al-Khwarizmi's era. The Abbasid Empire extended from India to Spain. Though there were internal conflicts, Baghdad remained a safe and prosperous city for long periods, allowing scholars to conduct research without concern for livelihood. The caliph's patronage freed them to dedicate themselves fully to the pursuit of knowledge. During Al-Khwarizmi's time in Baghdad, a particular school of Islamic thought, Mu'tazila philosophy, was very influential. Its followers emphasized reason and intellect, not blind faith. Caliph Al-Mamun himself adhered to this philosophy. This created intellectual freedom, allowing scholars to ask questions and explore new ideas. A curious mind like Al-Khwarizmi's could not have failed to flourish in such an environment. On one side lay Khwarizm, his distant homeland where the seeds of knowledge were sown in his childhood. On the other, central Baghdad, where those seeds grew into a mighty tree. When a young man entered the doors of the House of Wisdom, he probably could not have imagined that one day his name would give rise to the word algorithm, and that his works would be taught in European universities centuries later. Another remarkable aspect of his era was the bridge between knowledge and religion. Al-Khwarizmi knew the Quran, as well as Greek mathematics. Islamic civilization advanced by integrating these two streams, not by setting them in conflict. Religious knowledge provided moral guidance, while scientific knowledge offered a way to understand the natural world. The fusion of these dual powers was the real secret of the Islamic Golden Age. At a time when Europeans were memorizing fragments of the Bible by candlelight, scholars in Baghdad were building telescopes, mapping the stars, and solving algebraic equations using numbers. This contrast explains why Al-Khwarizmi's era was so exceptional. His talent was remarkable, but it was the era itself that made him extraordinary. Today, when we remember him, we do not see his birth merely as the birth of a man. We see it as a symbol of an era, a reflection of a civilization's confidence, and a testament to a society's openness. Every contribution of Al-Khwarizmi reflects the time that created him, nurtured him, and ultimately immortalized him in history. Al-Khwarizmi's name is inseparably linked with an immortal legacy: books. His brilliance was not only oral. It has endured through the ages as a repository of written knowledge. He authored works that were not merely for his contemporaries, but spread the light of knowledge for hundreds of years to come. These books place him at the center of history, and each of them was like a revolution in its own right. His most famous work is Al-Kitab al-Mukhtasar fi Hizb al-Jabr wal-Muqabala, known today as a compendious book on calculation by completion and balancing. This was not merely a book, but a landmark in the history of mathematics. Before this, mathematics was largely confined to arithmetic, accounting and trade, measuring land, or collecting taxes. But through this book, Al-Khwarizmi elevated mathematics to a new level. He systematically organized the rules for solving equations for the first time. Here, the term algebra was coined, from which the word algebra eventually originates. In the book, he demonstrated how to solve equations, particularly quadratic equations, in a detailed yet comprehensible manner. He did not use complicated symbols, but explained through simple examples. Imagine a 9th century teacher in Baghdad explaining to students, if you have a plot of land and face problems regarding its length and width, how can you convert it into an equation and solve it? In this way, he linked mathematics not only to abstract concepts, but also to practical daily applications. This is why his work is considered the birth of modern algebra. But his contributions did not stop there. He wrote another important work on arithmetic, Kitab al-Jam wal-Tafrit by Hizb al-Hind, or Book of Addition and Subtraction, according to the Hindu calculation. Through this work, Europe was introduced to the Indian numeral system for the first time. The numbers we use today, 0, 1, 2, 3, 9, trace their lineage to this work. Al-Khwarizmi established the concept of zero in the Arab world, which later reached Europe. Modern science, engineering, and computer technology would have been impossible without zero. Remarkably, this concept traveled from India to Baghdad through Al-Khwarizmi and then reached Europe through his book. His contributions extended beyond mathematics to astronomy. His book, Zij al-Sinhind, was a compilation inspired by the Indian astronomical works at Hanta. In it, he described methods to calculate the motions of the sun, moon, planets, and stars. This was not merely a text on astronomy. It was a scientific guide for timekeeping, calendar creation, and determining prayer times. Across the Muslim world, people determined prayer times by observing the sky, and Al-Khwarizmi's work made these calculations more precise. Another notable contribution was in geography. He wrote Kitab Surat al-Ard, the image of the earth. This was a revised edition of Ptolemy's Geographia. Al-Khwarizmi not only translated it, but corrected errors, listing around 2,400 place names with coordinates. It was an early scientific atlas of the world. While Europe remained in darkness, Al-Khwarizmi was mapping the globe from Spain to India with remarkable accuracy. He also wrote several treatises on astrology and religious applications. For example, he explained how astronomy could be used to determine the direction of the Qibla. For Muslims, praying toward Mecca is obligatory, and his research provided an accurate method to find that direction. The impact of his works was long-lasting. In the 12th century, when European scholars began translating knowledge from Arabic, Al-Khwarizmi's books were their primary sources. Robert Chester and Gerard de Cremona translated his algebra and arithmetic texts into Latin. When European students first encountered the word algebra, they may not have realized that it was an Arabic term that would revolutionize the language of mathematics. His name itself was Latinized as Algorithmi, giving rise to the modern word algorithm. On one hand, his algebra established the foundations of mathematics. On the other, his arithmetic books sparked a revolution in computation in the West. Remarkably, his books remain relevant even today. Modern students solving equations trace their roots to his works. Computers rely fundamentally on algorithms, a term derived from his name. Cartography, astronomy, even timekeeping. His writings laid the foundation for them all. Al-Khwarizmi's corpus demonstrates that he was not merely a researcher, but also a storyteller. Each of his books tells a story, of numbers, the sky, and the earth. He used his writings as a bridge, transmitting knowledge from India to the Arab world and then to Europe. Without his documentation, much of this knowledge might never have reached us. His pen was not merely ink. It was a force that changed the course of history. That force is still with us today, in every equation, every algorithm, every technology. When we speak his name, Al-Khwarizmi emerges not only as a mathematician, but as a pioneering thinker. His works were not just for arithmetic or astronomy. They marked the beginning of a new journey for human knowledge. His most famous work, Al-Kitab al-Mukhtasar fi Hizb Algebra wal Muqabala, gave birth to the term algebra. Its purpose was to solve practical societal problems, calculations in trade, inheritance divisions, land measurements, or legal documentation. But within it lay the effort to transform mathematics itself. He formulated a three-step method for solving equations, Al-Jabr, Al-Muqabala, and Al-Hizb, teaching how to break complex problems into manageable steps. This book was used as a textbook in European universities for centuries. Another significant work, Kitab al-Jam wal Tafriq by Hizb al-Hind, introduced the Hindu numeral system and the concept of zero to the Islamic world and later to Europe. Imagine it. Our modern digits 0 to 9 and the Hindu-Arabic numeral system owe their global spread to Al-Khwarizmi. This is why European mathematicians refer to him as Algorithmi, for which the term algorithm originates. Beyond mathematics, his interest extended to astronomy. His Zij al-Sinhind, based on Indian astronomy, was adapted to suit the needs of the Muslim world. It included practical astronomical discussions on planetary motions, solar and lunar positions, calendar creation, and determining the Qibla. This knowledge was essential for daily religious practices, such as prayer times and observing Ramadan moons. He also authored Kitab Surat al-Ard, a geography book created under Caliph al-Mamun's directive. It contained one of the most accurate maps of the known world, correcting and improving upon the work of Greek geographers, listing longitudes and latitudes with precision. Imagine a mathematician who was also an astronomer and a cartographer. When his works were translated from Arabic into Latin, it marked the dawn of a new era in European education. Medieval European science and mathematics were fundamentally built upon Al-Khwarizmi's books. One can say his works sowed the seeds of the European Renaissance. Thus, Al-Khwarizmi's writings were not mere books. They were keys that unlocked new horizons on the map of human knowledge. Each of his works opened a door, for which emerged the foundations of modern mathematics, technology, and science. In the magnificent halls of Baghdad's Beit al-Hikmah, scholars, astronomers, physicians, and philosophers gathered daily. Among them sat Al-Khwarizmi, a quiet yet revolutionary thinker. In his hands were blank sheets of paper, and with ink and pen emerged ideas that would transform the course of human civilization. He understood that the world of numbers could not merely be studied. It must be used, organized, and shaped into rules that would guide humanity in solving any problem. That rule is the algorithm. Today, when we use computers, open apps on mobile phones, or browse websites, algorithms work behind every action. But if we trace the origin of the word algorithm, we must go back to 9th century Baghdad, to the table of Al-Khwarizmi. When Europeans translated his works, they wrote his name as Algorithmi, and from this came the term algorithm. So, what did Al-Khwarizmi mean by algorithm? He developed step-by-step procedures that could be followed to solve any complex problem. For example, he demonstrated how to multiply numbers, divide them, or extract square roots. While these processes may seem simple today, they were revolutionary at the time. Greek mathematicians were largely limited to geometric thinking, solving problems through lines, rectangles, and triangles. Al-Khwarizmi, however, showed for the first time that arithmetic problems could be solved independently of geometry. Numbers could simply be organized and manipulated according to rules. The greatest revolution in his algorithms came from the adoption of the Indian numeral system. At that time, performing calculations in Roman numerals was nearly impossible. Imagine trying to multiply 3,789 by 246 using Roman numerals. The task would have been unbearably complex. Al-Khwarizmi adopted the Indian digits 0 to 9 and fully established the concept of zero. Zero was not just a number. It became the key to positional notation. This made large calculations much easier, and arithmetic could now be performed systematically, step by step. Another groundbreaking contribution was his method for solving equations in Al-Jabr wal-Muqabala. He explained that unknown numbers, what we now call x, could be determined by following a specific set of steps. First, bring the unknowns to one side, place the known numbers on the other side, and then calculate according to rules. This approach is a brilliant example of an algorithmic method. Each step was clear, logical, and repeatable, principles that underpin modern programming languages. Here's a small story. When the European translator Robert Chester translated Al-Khwarizmi's book into Latin in the 12th century, European students held a text in their hands for the first time that provided step-by-step rules for solving problems. They were so amazed that for a long time, the term Al-Khwarizmi was used simply to describe learning to calculate. In a sense, Al-Khwarizmi's name had become a common noun, but his contribution was not limited to mathematics. He created a new approach to human thinking. He showed that problem-solving does not depend solely on inspiration or talent. It can follow a systematic process. This was Al-Khwarizmi's greatest contribution. He taught people to break any complex problem into smaller steps, complete each step correctly, and ultimately reach a solution. This principle is still applied today, from mathematics to computer science, and even artificial intelligence. It is noteworthy that his thinking extended beyond numbers. He applied algorithmic methods in astronomy. For instance, he created tables to determine the positions of the sun and moon, which, when followed, yielded accurate results in a systematic way. He also transformed measurements into algorithms when drawing maps for geography. Regarding Europe, in the 12th century, when his books were translated, Europeans gradually abandoned Roman numerals in favor of Hindu-Arabic numerals. This not only simplified mathematics, but also revolutionized trade, taxation, land measurement, and even banking. In the early stages of modern economics and science, Al-Khwarizmi's algorithms were an inseparable part. Another significant aspect of his work is that he transformed mathematics into a language. Before, mathematics was mostly philosophical exploration or geometric play, but Al-Khwarizmi made it a tool for solving practical problems. Hence, some call him the Father of Algebra, and others even refer to him as the grandfather of computer science, because the foundation of modern computer science, algorithms, originates from this 9th century Muslim scholar. If we reflect, Al-Khwarizmi's contribution was not only numerical but also intellectual. He taught, logic plus process equals solution. This very concept guided human civilization from the Renaissance and the Industrial Revolution to the digital revolution. So, when we search for information online or ask questions to artificial intelligence today, the algorithms working behind the scenes were seeded over 1,200 years ago by the thinker in Baghdad, Al-Khwarizmi. The light of his knowledge was not confined to the Abbasid Empire. It had a profound impact on the foundation of the European Renaissance. When his 9th century works were translated into Latin several centuries later, they sparked a revolution in European scholarly circles. His Kitab Al-Jabr wal-Muqabala was translated into Latin in the 12th century by Robert Chester and later by Gerard of Cremona under the title Liber Algebrae et Al-Muqabala. Through this book, Europeans were introduced to the systematic form of algebra for the first time. In medieval Europe, practical applications such as commerce, taxation, land measurement, and inheritance division required this new mathematical approach. Consequently, his works were used not only in educational centers but also in courts, markets, and state administration. Another famous work, Al-Khwarizmi's Arithmetic, was translated into Latin as Algoritmi de Numero Indorum. This introduced Europeans to the Indian numeral system and the concept of zero. Indeed, the word algorithm derives from his name, Al-Khwarizmi Algoritmi, algorithm. Modern computer science, which revolves around algorithms, thus traces its roots back to Al-Khwarizmi. His geography book, Kitab Surat al-Ard, also reached Europe through translations. By correcting Ptolemy's maps, he created a world map that inspired European geographers. Notably, many explorers of the age of exploration indirectly benefited from Al-Khwarizmi's work. In astronomy, His Zij al-Sinhain had profound influence on European astronomers. The methods he used for determining prayer times, the Qibla direction, and calendar calculations opened new pathways for the study of astronomy in Christian Europe. Just as Ptolemy's Almagest had influenced European astronomy, Al-Khwarizmi's work served as its complement and correction. From the 12th to the 16th century, his books were core textbooks in European universities. Paris, Bologna, Oxford, all relied on his works for education. Through this, algebra became established as a distinct discipline in Europe, and Renaissance scientists built upon it to make new discoveries. In summary, Al-Khwarizmi not only contributed to Islamic civilization, but also created a bridge for human civilization. His writings and thought streams flowed from the Islamic world to Europe, playing a critical role in the revival of knowledge. European scholars such as Fibonacci, Regiomontanus, and Copernicus were indirectly influenced by his contributions. Thus, Al-Khwarizmi's knowledge illuminated not only the Islamic Golden Age, but also reached the European Renaissance, reshaping the course of human history. Al-Khwarizmi was not merely a mathematician. He was a philosopher, astronomer, geographer, and technical thinker whose work linked the scientific progress of the medieval Islamic world with the Renaissance in Western Europe. Although his work centered on mathematics, particularly algebra, its influence extended far beyond. By applying his theories and methods in science, technology, and astronomy, he became a vital source of inspiration for European scholars, mathematicians, and engineers during the Renaissance. His major works, especially Al-Kitab al-Mukhtasar fi Hizb al-Jabr wal-Muqabala, were invaluable not only to the Islamic world, but also to European education. For instance, in the 12th century, European scholars completed Latin translations of his works. Scholars like Robert of Chester and Adelard of Bath translated Al-Khwarizmi's writings into Latin and incorporated them into European curricula. Through this, the Hindu-Arabic numeral system and concept of algebra were introduced in Europe, providing mathematics with an entirely new dimension. Mathematicians like Fibonacci, whose Liber Abbasid later revolutionized European trade and mathematics education, were clearly inspired by Al-Khwarizmi. This connection was not limited to numbers and equations. It also stimulated new research in European education. Al-Khwarizmi's contributions to astronomy and geography likewise had widespread impact on science and technology. In Zij al-Sinhain, he documented planetary, stellar, and solar system calculations, along with mapping and celestial computation methods. When European astronomers translated and applied these works, they were able to create more accurate maps and navigate ships more precisely, directly aiding the age of exploration. Finally, in technology and engineering, his mathematical methods, especially algebraic theory and numeral systems, opened new possibilities for European engineers in calculations, designs, and architectural projects. During medieval Europe, when large constructions and fortifications were underway, engineers used equations and algebraic methods to perform precise calculations. This not only advanced mathematics, but also allowed for technological and architectural progress. Similarly, Al-Khwarizmi's influence in business and economics was highly significant. His writings simplified and systematized commercial calculations. Through the Hindu-Arabic numeral system, European merchants were able to perform complex calculations with ease. This mathematical method later became indispensable in banking, commercial contracts, and accurate tax computation. In other words, Al-Khwarizmi's work impacted not only scientific research, but also the development of social and economic structures. A notable aspect is that Al-Khwarizmi connected science and technology with practical life beyond the traditional education system. His equations and algorithms were not merely theoretical. They could be applied to solve real-world problems. For example, his methods were employed in land measurement, tax calculation, and water resource management. This approach guided European scholars during the Renaissance to innovative and practical thinking. Al-Khwarizmi's scientific philosophy and systematic reasoning strengthened the foundation for the European Renaissance. The continuity of his work and methodical analytical approach later played a critical role in the European scientific revolution. Complex mathematical concepts, such as equation solving, geometric analysis, and the use of numbers, inspired European scientists to conduct new research. As a result, not only mathematics and astronomy, but also physics, chemistry, and engineering entered a new phase of development. One of the most enduring impacts of Al-Khwarizmi's work is the foundation it laid for modern technology and information systems. The concept of computer science and algorithms today traces its roots to Al-Khwarizmi's algorithms and mathematical methods. The word algorithm itself originates from his name, demonstrating that his ideas and systematic research have influenced not just the medieval period, but also modern technology. In summary, Al-Khwarizmi's scientific and technological contributions were multifaceted. His work served as a crucial bridge for the European Renaissance, opening new horizons in mathematics, astronomy, geography, engineering, architecture, and commercial accounting. His thinking and writings became a source of inspiration for scholars, scientists, and engineers, and his influence is still evident in modern science and technology. Al-Khwarizmi is remembered not only as the father of algebra, but also as a pioneer of scientific culture and technical reasoning, whose impact is visible in every level of contemporary scientific and technological advancement. Al-Khwarizmi was one of the greatest mathematicians, astronomers, and scientists of the Islamic Golden Age, who made a revolutionary contribution to the scientific thought of his time. He was not only the founder of algebra, but also left a lasting impact on scientific philosophy. He is particularly honored with the title Father of Algebra, which applies not only to the rules and methods he introduced in algebra, but also to his visionary perspective in mathematics, astronomy, geography, and information science. His major work, Al-Kitab al-Mukhtasar fi Hizb al-Jabr wal-Muqabala, is recognized as the first systematic explanation of algebra. In this book, he organized rules for solving equations, working with positive and negative numbers, solving arithmetic problems, and providing examples of practical applications. Previously, mathematics was often taught in a mixed and fragmented way across different branches, but Al-Khwarizmi established algebra as an independent field. This is why he is recognized as the father of algebra. The significance of his work was not limited to algebra alone. Al-Khwarizmi introduced the Hindu-Arabic numeral system to the Western world, which gave European mathematics a new dimension. European scholars translated his works into Latin and incorporated them into educational curricula, marking the beginning of modern mathematical studies in Europe. Mathematicians like Fibonacci were clearly inspired by Al-Khwarizmi's work, and in his Liber Abbasid, he introduced Hindu-Arabic numerals and algebraic concepts to the European education system. Al-Khwarizmi's contributions were not limited to theoretical mathematics. His methods could be widely applied to solve real-world problems. For example, his mathematical methods were used in land measurement, taxation, business calculations, water management, and maritime mapping. This enhanced Europeans' ability to solve equations and think analytically, laying the foundation for the scientific renaissance and the scientific revolution. In astronomy and geography, Al-Khwarizmi made significant contributions. His Zij al-Sinhind included methods for determining the positions of stars, planets, the sun, and the moon, as well as celestial maps and computational techniques. When European astronomers translated and applied these works, they were able to produce more accurate maps. This was particularly useful for navigation and maritime operations. As a result, Al-Khwarizmi is recognized not only as the father of algebra, but also as a pioneer of modern scientific methods in astronomy and geography. Another long-lasting impact of his work is the development of the concept of algorithms and computation. The word algorithm derives from his name, proving that the foundation of modern computer science and information technology lies in his writings. Concepts such as solving equations, number systems, and step-by-step analytical methods now form the core of computer programming and algorithmic research. In terms of legacy, Al-Khwarizmi established a permanent influence on education and scientific philosophy. European scholars, mathematicians, astronomers, and engineers followed his methods to initiate new research. The principles of algebra, systematic equation analysis, and the use of numbers continue to serve as an unshakable foundation in modern education. Even in the 19th and 20th centuries, his thinking influenced modern mathematics, physics, chemistry, engineering, computer science, and information technology. Al-Khwarizmi's approach emphasized the scientific method. He demonstrated how theoretical knowledge and practical problem-solving could be integrated to strengthen scientific thinking. His systematic analysis, logical solutions, and pedagogical writing have been considered milestones for scientists in subsequent centuries. This shows that Al-Khwarizmi's impact was revolutionary not only in algebra, but across the entire field of scientific philosophy. In short, Al-Khwarizmi received the title Father of Algebra for his enduring and foundational contributions to algebra. His legacy remains evident in scientific and educational systems today. The way he introduced systematic thinking in mathematics, astronomy, geography, and technology provided a strong foundation for the European Renaissance, the scientific revolution, and modern information technology. His ideas and writings have been a continuous source of inspiration for scholars, educators, and scientists. His name is remembered not only in the history of mathematics, but throughout the history of science and technology. Al-Khwarizmi teaches us that an individual's research and ideas are not confined to their own era. They can leave a lasting impact on the progress of human civilization. He was simultaneously a mathematician, scientist, philosopher, and educator, and his influence is still clearly visible in modern science, technology, mathematics, and education. His life and work demonstrate that knowledge and research are not merely theoretical. They are essential for solving practical problems and advancing human civilization. Al-Khwarizmi passed away around 840 CE. The exact date of his death is uncertain due to limited historical records from the Abbasid Caliphate, but historians generally estimate this period. Despite his death, Al-Khwarizmi's contributions remain alive through the ages. He is remembered not only as the father of algebra, but also for his lasting impact on scientific philosophy, astronomy, geography, and computational methods. In the modern world, Al-Khwarizmi's name is associated with algebra and algorithms. The term algorithm originates from his name, demonstrating the lasting influence of his ideas on modern computer science and information technology. His works are taught worldwide in educational systems, and his principles continue to be applied in mathematics and technology. Various scientific and technological institutions, educational organizations, and international scientific communities honor him as the father of algebra and a distinguished scholar. The commemoration of Al-Khwarizmi is not limited to education or scientific research. His name and works are cited in international mathematics and science conferences, books, and educational programs. His concepts and methods remain applicable in modern mathematics, computer science, engineering, astronomy, and information technology. In this way, Al-Khwarizmi is still not just a scholar of the past, but an eternal source of inspiration for modern scientific thought. In summary, although Al-Khwarizmi's death physically removed him from the world, his knowledge, thinking, and scientific contributions remain alive. Scholars, researchers, and technologists continue to honor him, and his influence on mathematics and technology endures. For this reason, he is remembered not only as a luminary of the Islamic Golden Age, but also as a timeless scholar of human civilization.